Welcome to Energypreneurs, the podcast where solar power batteries and electric vehicles come together. I'm your host, Sohail Hasni. When we combine these technologies, something powerful happens. On this show, I speak with founders, engineers, and investors who are building this fantastic new energy system. Thank you for joining. Bill is coming as a returning guest to discuss, among many things, the impact of free electricity we will have globally, starting in Australia, then how the V2G, the vehicle to grid, is going to impact our energy transition. He is based in California and his perspective is quite interesting. Thank you for joining. Hi, good morning, Bill.
Good morning. How are you, Sohail?
I'm very good, thank you. Yeah, good to connect after quite some time, no?
Yeah, it's been a little bit. The market continues to evolve and mature, and I guess we do too.
Yes. I'll let you introduce again. Thanks for coming back to the podcast. I think you have been one of the earlier guests I had, and those times it was audio only. Now, good to see you back.
Yeah, and I still listen to the podcast and enjoy the different guests that you have on. I think one of the things that I like about your podcast is that you have a variety of guests and talking about a variety of solutions in the space. But to just recap, I started out in the energy efficiency space years ago. We did building envelope, lighting upgrade, HVAC, anything that made sense for our clients. But because we were doing a lot of that work, we had a lot of large national accounts here in the US that we were working with that were having problems with solar installations in 2008. And essentially we got pulled in to fix these solar problems for our clients. And we basically pulled apart and put back together about 100 projects in a 6-month period of time. And so I always tell people we got paid to learn. We wrecked the economics on those projects, obviously, but that was our intro to the industry. And so from 2008 through 2017, we did a lot of rooftop projects, some ground mount, but all of it behind the meter for clients and finance groups that we were working with. And then 2020, started doing more work on the microgrid space. I'd always been interested in batteries, but I actually had some friends that were involved in the cannabis space that needed power, but I also had a lot of friends in the controlled environmental ag space. And that kind of pulled me in, and we started working on various projects and more focused on the development and finance of these projects, own and operate or develop them and bring in a finance partner. More recently, I was developing a lot of projects over the last couple of years, and we had multiple solar storage and a couple of microgrid projects that were solar storage and cogeneration. And we're looking for a battery manufacturing partner, and I ran across a company called Clearbook Energy Solutions, and they're building a facility in the US, which was fiat compliant. And so started working with them just on the battery side of getting battery quotes. And they asked me to join the team, which I did in December of this year. So working with them, and it's an interesting company because it's actually a subsidiary of a company called Clearbook Global. Clearbook Global is, they established about 20 years ago by a gentleman named Elliot Whistler, and Clearbook manages about 13 billion in assets globally, investment management, but also works with and advises Itochu, Mitsui, Mitsubishi, has worked with LG on their venture arm in the past, as well as multiple other national and international companies. And they were working with LG, and at the time, LG decided they didn't really want to be in the C&I space. They were more focused on the large cell production and large utility projects. And so the team came to Elliot and said, we want to start a battery company. And that's what they did. And that was 6-7 months ago. Currently, the energy company now has an MOU signed with Kazakhstan to build a battery manufacturing plant there, as well as implement VPP. We are in the process of not breaking ground because it's an existing building, but we're going to be putting in assembly and manufacturing in West Virginia. We're in the process of acquiring a battery plant in the Philippines, actually, buying out a Chinese investor, and we're a vertically integrated company. So we do battery manufacturing. Obviously, we have a VPP platform, and then we have a subsidiary, essentially, it's an SPV set up as an IPP, finance, own, and operate these projects. And a lot of our projects are here in the US are CNI type or small front of the meter, but we're working with quite a few data center groups here in the US. And that's what we're up to, and pretty interesting time in the market. I've never seen so much activity in the market and so much capital moving around in the market, and just so much adoption of all the technologies and all the things that people like you and I have been working on for years and the industry has been talking about. But actually seeing these kind of projects and technologies being implemented now is amazing and almost crazy in some aspects.
Yes, absolutely unbelievable as well. No?
Yeah, it really is.
Because I was in Melbourne in our house last week, Australia Open, and it's 45 degrees or 46 degrees. When we lived in the house, now we don't live in the house, rented out. When we lived in the house, if it was 46 degrees, you would just say, oh my God, my air conditioning bills is this. Now we are sitting and enjoying. I went for the game. My family was down there. Free electricity. And you not only getting for your free consumption, I had a VPP set up where somebody would battery out and I was earning money. I said, we live in a different world. No?
Yeah, Australia's been really ahead of most other areas with their VPP, and there's just their battery and their solar programs.
Yeah, especially the $7 billion subsidy now. Everybody installing 50 kilowatt hour battery that I did before the subsidy came in. Yeah, it's amazing. Sorry, go ahead.
Yeah, I think Australia is, for like residential as an example, I know that all the different people that I talked to, as well as reports, solar getting installed at like $1.25 a watt for residential. And here in the US, if you can get it at $2 a watt for residential, you're really lucky. So they've really perfected the model, in my opinion, by layering in low cost of installation, coupling it with battery storage, the right incentives. They're doing it right. And I think that from what I've seen, Australia also has some of the largest renewable microgrids in the world right now that are functional and run primarily on renewables. And so it's really encouraging to see that.
Whole Western Australia, because earlier, about 2-3 years ago, when I was talking to Horizon Power, they were actually taking out distribution lines. Those dingy lines go to server communities saying, okay, let's make it an isolated grid because it's so much cheaper and it makes sense.
Yep. Yeah. Anytime that you can produce and consume within local, it goes back to the saying used to be think local, act local, consume local, same kind of thing. You can do that with power. You can do that with a lot of different commodities and resources.
Yeah, I interviewed a gentleman by the name of Stanley Choi from Sani last month, a couple of months back, and he was telling the same thing. They are converting mining towns, solar, battery, and electric trucks. So there is nothing left. This is the real, true sense. Electrify everything. Anything moves, not electric, no?
Yeah, a couple of years ago, I was talking to some of the folks at Caterpillar, and they make all kinds of big equipment, including dump trucks. And at the time, I think this was 2 or 3 years ago, they had a dump truck that, one of the large mining dump trucks. And this was at a mine that basically mine on the top, and then they transport to the bottom. When this dump truck is fully loaded, as it's driving down the hill, it generates 4 megawatt hour. They dump it. It's got its own power to go back up the hill. And so it's generating its own power as it goes. They had a backhoe that they had developed, that large backhoe, obviously. It would generate, I think it was 1 megawatt hour when the shovel was coming down. So figuring out ways to make that kind of equipment more efficient. And from operational perspective, from the mining operator, diesel-driven power is very expensive. So if you can create enough power to offset, even if you're talking about 20 or 30% of that diesel, it's bottom line OPEX savings. But a lot of times now with the technologies that we have, they're able to create microgrids that are running entire mining in small towns now at this point in time.
Yeah, your mining truck giving me an idea. I think I posted many years ago on LinkedIn. So if you have those mining track, or you can do almost like a train or tram. So you take on the top of a hill, get them fully charged on solar, and let them slowly come down the entire night. As they come down, keep on discharging.
Yep.
and then use the daytime energy to go back up. So that could be a gravity storage as well, no?
Yeah. Yeah. It's interesting. Some of the technologies are interesting, but the automation and AI has created like interesting just power consumption in the market. As an example, we used to do a lot of solar for logistics facilities, Amazon, FedEx, UPS, and we're talking maybe 10 years ago. We would go out and we would install solar onto a facility like that for net metering to get rid of their electricity usage at the site. And these are big facilities. You're talking about 500,000 square foot distribution facilities. And at the time in warehousing, there's not a lot of energy consumption. There's some, but not a lot. And a lot of the projects that we did were about 1 megawatt. That was a lot of the average. We had a client this last year that was building a large logistics facility. And that logistics facility was in California and fully automated, though. Look at 10 years later, fully automated. It's conveyors, it's basically robotic forklifts running around, full automation. And this site, about 1 million square feet, needed a microgrid because they couldn't get a grid connection fast enough. And so that site, we ended up designing a microgrid for them that was about 6 megawatts of solar, 5 megawatt hour battery, and 10 megawatts of linear generators. So the site consumes about 100 million kilowatt hours a year. Same customer, 10 years later, and that site is consuming almost 100 times more power that it consumed 10 years ago, just because of the energy intensity of that particular facility. Now, they were doing EV charging and some other things there. Just a prime example of the amount of power that's needed for AI and automation in the industry right now. And we see it more and more. The other thing that we're seeing, Sohail, is that everybody talks about the hyperscaler sites and the gigawatt sites and the 100 plus megawatt sites and everything going on in the market. But we're seeing more and more inference sites. So basically like edge AI. We're working with a group right now that they're going to be deploying 1 to 5 megawatt sovereign AI sites at hospitals and universities. And we're working with the EPC and them to deliver these in modular units because, like as an example, at a hospital, so the hospital needs AI. They can't use outside chat or some of the outside AI because if they put on hospital documents, private documents into the public market, all of a sudden there's HIPAA violations and all kinds of other potential privacy violations. And so they're putting in a sovereign AI unit that runs all the AI. It's got an LLM on site so that there's no data leakage. But that site, 1 megawatt, is going to consume 8 million plus kilowatt hours per year. The site doesn't have the grid capacity to be able to provide that power. So we're bringing in the power infrastructure, cogeneration, absorption chillers, battery storage, grid control, and the modular AI data center. And it's going to run all the AI for the site. But as that hospital advances and uses robotics and other things, the AI grows and adopts and creates that opportunity for the hospital. And it has zero latency and it's 99.995% guaranteed uptime. It makes that hospital more resilient and more self-reliant. And they're able to lower the energy costs because we're doing it under a fixed cost power project. So we're seeing a lot more sites like that. We're seeing a lot of sites in the 10 to 30 megawatt range that are close to major off-takers, airports, defense industries, major corporations where they want to have AI close by or they want to have AI on site to be able to provide that compute value. And again, these sites need to stay up and running. You need minimal latency to deliver that. We're seeing a lot of those kind of projects in the market right now as well.
But I think still, I personally think the power consumption for AI has been overstated, like the way people are doing when the electric vehicle first came in. I was in a conference in London. Oh, our economy will double. And I said, listen, it will take 2040 before all of London cars are electrified, maybe 2050. So let's not scare people off. But having said that, The interesting thing that will happen, in my view, that AI getting concentrated because one maybe server will serve everybody, some
Yep.
request like in hospital. But the robots will not be, no? The robots will be where they consume, where
Yeah.
they run locally, solar powered, maybe a battery storage.
Yep.
That would
Yep.
redefine microgrid and mini grid. If once you have like a tiny robot area city
Yep.
that has a
Yep.
lot of robots, lot of elderly population or commercial activity or industrial activity, suddenly can create huge demand.
Yeah.
Do you
Well,
have any
that's,
views as where we are going with that?
yeah. I mean, that kind of goes back to what I was talking about the logistics facility, because a lot of it is conveyor belts and other equipment. An electric forklift it's a robot, right? It's
Yep.
running around, it's grabbing equipment, it's grabbing pallets and other things within the facility, and it's moving it from place to place. And like I said, the load of that particular client over the last 10 years at one of those sites, it's almost 100x more because of that automation. So if we look at any other type of facility that's going to be using robotics, and robotic can be a robot running around, but robotics can be an arm that's articulating and moving things around. It could be automated equipment. So there's a lot of additional energy consumption that goes behind that. And with those type of facilities, the robotic systems need that AI on site or very close by because of that latency. They can't have a lag, but it'd be like if you or I were thinking about doing something, but our brain, like we wanted to move our hand, but it was like a 1 second delay. Same thing with robotics.
You're processing, right?
Yeah,
That's the way the movies do. Yeah. Oh dear.
they they need that brain at that computer brain basically at the site or close by the site to eliminate that latency. And both the robotic system and the compute system, it's got to stay up and running. So
Yeah.
resiliency becomes a real thing and a challenge for a lot of these types of projects.
Yeah, I worry about that when you're going a very high speed on a Tesla or any electric car. It's a self-drive, and then you suddenly saying the brain is not here, maybe fully.
I don't know, Sahel, if you saw, I think it was in the last 2 months, there was a substation that blew out in San Francisco. And so the power went out for a large area. Well, the automated vehicles in that area, they stopped because they couldn't communicate. And so there was videos of like vehicles literally stopped in the middle of intersections and on the road because they couldn't communicate because everything was down. So, it is an issue,
Is that
right?
the Waymo one? I saw, yeah, I think
Waymo. Yeah.
was it because of the power failure? Or there was another incident where there is a traffic signal lights were flickering, and these cars did not know
Yeah.
what to do because that's something that has not been programmed.
No. Yeah, part of it was that. And then my understanding is part of it was the power failure because when the substation blew out, some of the cell towers and some of the other communications were out because there was no power. So all of a sudden, between the lights going out and some of the other issues, the robotic cars didn't know what to do all of a sudden. So it's the same kind of thing. And as we automate, it becomes more and more critical for you to have redundancy in the network itself. And the network is not just the compute, but the energy infrastructure. You've got to have intelligence in that energy infrastructure to be able to respond to whatever's going on in the market. But going back to what we were talking about earlier, in Australia, because of VPP, certain times of the day you have free electricity because they've figured out how to balance that load and be able to create opportunity within that demand or that lack of demand within a market. And I think that as we expand in AI and automation and robotics, you're going to see more and more of that. It's the VPP combined with AI creates an intelligence of the grid and intelligence of the assets that are connected to the grid, because they have to be able to communicate. They have to be able to work together, because if they don't, we're going to end up with situations that are way worse than the substation in San Francisco, because you have very large loads that are super variable. Some of those large data center sites and some of the compute, they can go from like 100 megawatts to almost nothing, depending on what they're doing. like in milliseconds. So if you don't have systems that are as smart as whatever it's powering, it creates critical issues over time potentially.
Yeah, also you need tons and tons of redundancies, exactly as you said, because today's Uber drivers globally, if God forbid suddenly the GPS shuts down, they will never be able to come home. A lot
Yeah.
of people will not be able to find their home as to, because I learned that in a personal example as an early adopter. I had those old Garmin GPS. We are in Pakistan in 2005 or 6. I had a project. And of course, it's a little GPS, fancy things. I had the restaurants and our office or the resident mission that we call it, where we used to stay. And we went. And coming back, there's no GPS. Because I think that coincided with the US attack on Iraq or that war that started.
Oh,
So the
yeah.
whole GPS in the region was shut down. I think that's what may have been. Anyway, there was no GPS.
Yeah.
And it was so difficult to call people on walkie-talkies saying, hey, how do I come back? And because we just went for a walk, we should not have been.
Not too long ago, I was driving to an appointment and I hadn't been there before. It was an area that I hadn't been before. And my charger in my car wouldn't charge. And I was using my GPS on my phone, right? So I was probably 2 or 3 miles from where I needed to be. So I knew approximately, but I didn't know exactly. So I stopped at a gas station and I asked the guy, I said, hey, do you have any maps? He looked at me like I was crazy.
What is that?
He was like, we have maps. And he was a younger guy, but he's like, maps. What are that? What's that?
That was a standard thing, I think, old days. I remember driving around Melbourne, we had something called Melways. I knew that my house is on the page 29. So you will go saying, oh, Mike, can I just borrow and have a quick flick through? Because I'm lost and left my Melways in the house. Yes. Interesting. You mentioned one other thing that sort of, and I want your views on. Australian government has announced, the details are still not being in the public domain yet, that there will be 3 hours of free electricity as a default tariff from 1st of July, which I find really fascinating because peak tariffs have been everywhere. But this is an off-peak tariff with zero price. Suddenly it gets attention, right? The impact could be huge and it's such a smart policy. What are your take on this?
It is, because one of the challenges with renewables is that in a lot of areas, we put so much renewables online that at certain times we have to curtail it or we have to push that power somewhere else. And so I'm in California, and as an example, some days California creates too much solar essentially to feed into the grid. And so the grid operators actually use the Western grid as a battery. And what I mean by that is that when they're creating excess power, they'll push it into Utah and Nevada and other areas. And they're basically paying those other areas to take our power. And in some areas, the cost of power at the wholesale level is negative at those points in time. So California is basically giving free energy to some of the other Western states. Instead, if we had enough batteries and we had the same program, we could give free energy back to our customers here in California. So doing that kind of program in Australia is really smart, because what they've realized is they do have excess capacity. And if they can basically just provide that, it's a subsidy.
It's a demand shift.
It's free excess. You've got that free excess power that can be provided to the customers. So it's a benefit to the overall grid and the customers anyway.
Yeah, and also the argument that the people in condominiums, people are in the multi-story apartments who do not have access to roof, can also benefit out of this, so that the income disparity or whatever you want to define, but the issue is it's an access for everybody.
Right.
And it benefits the sort of low duration curve in a way, because you're dragging those evening dryers, washer, heating, slab heating during the day, because the electricity is free, and electric car and everything, right? Pile up your demand. Because right now in the middle of the day, when you have a really sunny, hot day, sort of system demand can be negative in the middle of the day, pushing to negative prices because the big coal power station trying to stay on and bidding negative price, right?
Yep. Yep. I think too, with those kind of opportunities to be able to provide energy to lower income citizens or people that are disadvantaged, if you have an excess capacity, why not provide it? The other thing, Sohail, I don't know if you've seen, but there's companies now that are doing what are called balcony solar. So they make panels that you can basically mount on your rail. And I know Utah has passed legislation that allows you to put in balcony solar and you can just plug it in. So you plug it straight into your AC wall and it's running your meter backwards essentially. So it's an easy way for somebody to plug solar in and reduce their cost overall of their energy, even if they're in an apartment like that where they don't have a rooftop and maybe it doesn't run their entire home. It does allow them to reduce their cost in one way or another. So I think that we're going to see a lot more of that. I know that we've seen community solar here in the US has been fairly popular for the last few years. It's really started to take off where you'll put in an array in an area and then that power gets sold into the community. And a lot of times it might be like maybe a third of it goes to commercial customers, a third of it goes to small commercial customers, and maybe a third of it goes to like low income or disadvantaged communities. So it's early stages of democratization of those energy assets. But again, as we like with VPP and AI and some of this excess capacity, you can really start to optimize those costs, figure out how to essentially create more abundance within that excess capacity than what there has been in the past.
Yeah, balcony solar is something so powerful. Although we are not allowed to do that in Australia, I wanted to put a fence with solar panel because solar panel is so cheap now.
Yep.
And I interviewed someone, Dr. Enebish. He actually has the boundary of his house with solar panels and he pushes back to the grid. So yeah, once everyone starts doing that, and balcony solar is really an amazing thing. And if you are able to plug in directly, wow. So it comes with its microinverter, right?
Yeah, it's got a microinverter. You can just plug it straight into your AC.
Because I thought IKEA was selling them in Europe.
I think they are. I think they have been, but I think Utah just passed that legislation in the last few months. And I have seen a couple other states that are looking at it. It's encouraging to see that type of adoption at the state level. Again, consumers do have that kind of choice, even if they're in an apartment or similar situation.
Yeah, so then what happens? Like in Australia, we have maybe around 35,000 megawatt of behind the meter solar. National electricity market maybe 33,000, 34,000. Total installed capacity maybe around 55,000 all over Australia. There's no balcony solar. People start putting balcony solar. Maybe in 5 years' time, suddenly people, all first generation people who put solar, 17% efficiency replaces their solar panel with something, say 30%
Oh, yeah.
efficiency. Flooded with electricity everywhere.
Yep.
Even if you have a full-time robot in the house, two of them, it's not going to take you more than 5 or 10 kilowatt hour max, maybe 5. Because a
Right.
kilowatt hour is a lot of energy, right?
Yeah. Oh, yeah. Yep.
Electricity will be free, no?
I would think, and there has been studies on the long-term impact of renewables creating that type of cost scenario. And again, we see it with curtailment. It stops you from feeding that because they got too much capacity in the grid. But again, if you're able to do it correctly, all of a sudden you've got a negative cost of electricity. And, you know, that creates a lot of opportunity in the market, obviously for the homeowner or small business to be able to get your electricity costs down to zero or close to zero. That's a huge savings or improvement. But even like large scale manufacturers or large energy users, if they're able to essentially save money, that'll keep them open. So just as an example, we talked to a steel plant this last year and think the steel plant it was about 200 million kilowatt hours per year. And the cost difference between nighttime electricity and daytime electricity for them was about 2.5 cents. They didn't run any shifts during the day. They ran all their shifts at night. And what they told us is that if they ran during the day, they wouldn't be able to stay in business. So that 2.5 cents difference for them was the difference between making a profit and going negative profit and going out of business. So even those small numbers can add up to huge dollars for even large companies.
Yeah, I mean, energy cost still counts. But the fun thing is, as electrification of everything happens, all cars become vehicle to grid. That means you solved your battery
Yep.
problem. There's
Yep.
battery everywhere, and you have solar everywhere. I don't see any reason why some of the power companies might actually exist in remote areas. The whole business game changes. Then you have drone deliveries, I guess that's also for free, right? And if your
Yep.
EV, self-driven EV can do 100K overnight for free. So whether I'm selling to a next door customer or selling to a 100-kilometer away customer, it doesn't matter, right?
Going back to the example that I was giving earlier on that logistics facility. So that customer, we gave them a PPA option and we gave them a cash option. So their levelized cost of energy, including O&M, gas costs, everything else, their levelized cost of energy was about 8 cents a kilowatt hour fixed for the next 20 years with that equipment. Their quoted cost from the utility was 22 cents. That's a huge 100 million kilowatt hours times that much savings over a 20-year period of time. It's a massive savings. And the utility was not going to be able to connect them for 3 years. The microgrid was built in less than 12 months. So in less than 12 months, they had all the power that they needed, and it has like a 99.9% uptime. So it's more reliable from the grid. Going back to your point of the utility, why do you need the utility at that point in time? If you can create that much power at a site that's more reliable. But then the interesting thing is that because that site has excess capacity designed as is, when the grid is connected, the batteries and some of the generation capacity from that grid can actually join a VPP and generate additional revenue. In 2 or 3 years, when the grid connection comes in, they'll generate, in California, they'll generate another $150,000 to $200,000 per megawatt hour on those batteries when they're providing grid services in the evening when the facility is not using those batteries. Again, they're not going to get to free, but they'll get pretty close to free energy when it comes down to it compared to what they would have been paying.
Yeah, I can see absolutely that's happening. But at the same time, some of these businesses are not taking out the potential of V2G fully yet,
Yep.
right? And
Yep.
V2G need not to be vehicle to grid on your Toyota Prius. It could be on your big boat. It could be on a container ship. I don't know.
Yep.
So once this storage, mobile storage fits back to the grid, it can feed where it is needed, no? So what's your view?
Yeah, no, it's still early, but I agree with you. It's the thing about vehicles is that a vehicle will have here in the US, it might have 50 kilowatt to 100 some odd kilowatt hour worth of charge. And I know some people that are putting big batteries on their home from a kilowatt hour perspective, but I don't know anybody that's putting 150 kilowatt hour battery on their home, but they'll park a 150 kilowatt hour battery in their driveway. And, that battery is a great grid asset. And most of the time I've got a couple of vehicles and they're parked in my driveway 95% of the time, especially with remote work and everything else that's going on in the world. You don't drive that thing very much. So if you got a battery in it, it's a pretty good asset if you can do vehicle to grid. And I think that we've seen examples. There's one group that I know that they're running, I was in the Northeast, they're running vehicle to grid on some school buses. And each of those school buses, and I don't remember the exact size of the batteries. It was 200 to 300 kilowatt hour, I think, in those buses. But those buses are earning, I think it was $40,000 or $50,000 per year participating in a vehicle grid program. That's so it's basically free gas equivalent for those buses. Because when the bus is sitting there, it's getting paid $40,000 to $50,000. From an electricity perspective, it doesn't cost that much to operate that bus. So all of a sudden, that bus is not a OpEx for the school. It's actually a revenue generator for the school. Plus, it provides a little bit of resiliency if needed. So we're starting to see some of those kind of programs. And I think, to your point, if everybody got electric vehicles, all of a sudden you've got excess free energy that's out there, being able to charge and discharge the vehicle that's sitting in your driveway. It's going to create revenue. You see it pretty consistently now in residential batteries. If somebody signs up for a VPP, they get paid to utilize that battery. And the other thing that we're seeing more too now is the utilities want batteries in the market because they've got grid constraint. They can't get additional generation. And so they pay really strong revenue for batteries in the right markets. And it's not just for charging and discharging that battery, it's for frequency regulation, capacity. There's other programs now that those batteries are being used for, especially as a fleet. So like you got stationary batteries, but you could do the same exact thing with vehicle batteries once you've got the scale and the network established.
Yes, V2G and electric vehicle, people still think that as a fancy toy. So that always reminds me the Steve Jobs quotes that I think he said that iPhone was the killer application. And look how iPhone eliminated the whole, I'm a photographer too, the whole camera industry got shaken up. Everybody became a photographer. And the videography, serious videography, people are using iPhones now, cinematography.
Oh, yeah. Yeah.
For document storage, management. I don't know, thousands of uses that came up with iPhone. It was just a phone. And similarly, I think the electric vehicle is seen as just a transport. Okay, I have a gasoline car, but it's not appreciating that tool can potentially bring zillions, maybe different level of thinking. And out of that, maybe 50 or new income stream would come up that we even cannot think about because electric vehicle, battery storage, cell, that's enough. No?
Yeah. Yeah.
Plus AI.
Oh, yeah. Yeah.
And a robot coming to you as a doctor, maybe. I don't know.
Yeah. People like you and I, just 3 to 4 years ago, we would sit around and talk about these things. Oh, can you imagine? What do you think about this? These things are actually taking place today in the market and they're starting to scale. And like, I have friends that we were 10, 15 years ago, we were talking about free electricity because of exactly what's going on in Australia. It's happening and you're not going to stop it because once the general public understands that, it's working for him. I want it too. Why can't I have it? Because it's working over there. Once you have a working model, it just adopts because it's like you said, the iPhone, it's the killer app. There's still people that carry cameras around, but very specific.
I do too, please.
Right? But you don't hardly see a scanner anymore. I've survived I'm always on my computer. I'm always on calls, but I can go days without my computer because I got all my files on there. I've got my email on there. I can communicate with the entire world through my phone, which you used to not be able to do.
You have thought that this phone, which all carry, it's a level meter. You hang out a photo frame and say, is it level? I remember one of my doctor friend many years ago when I first bought my iPhone, he was saying, why did you buy this? This is a show off. What's the use of this? You have your phone, because he had a phone, one of those Nokia in his car. He said, why you carry? And I gave him okay, these are the 5 uses I'll do. Okay, if I go fishing, catch a fish, I can call my wife saying I got a fish coming. So don't wait. And I could not think. But then the way the innovation is happening, this metering, the measuring, the level one, then you can measure a table, right? What's the
Yep.
length? The phone. Unthinkable things have come up, which I don't think if you put the best 100 brain in a room, lock up for them years, they would not have come up. It's sort of people looking
No.
at, why can't we do this? Yes, we can.
Yep.
I don't know where the limit is, but people have to appreciate that electric vehicle is going to break many monopolies and businesses and centralized
You-
power.
I always tell people efficiency always wins. Because no matter what, if it's more efficient, it always wins. It's always going to win in the end. And if you have a vehicle that can do all the things that we're talking about, it's way more efficient. It's the killer app plus the efficiency combined that it's going to win the race. It's just a matter of time at this point in time. But with all the technologies that we're talking about, there's like a 1+1=3 accelerator that's going on in the market because of AI adoption and some of the things that you're able to iterate on a much faster basis. There's things that we're learning that through AI and medicine and all these other applications that are taking place, but there's automations that are taking place that are going to allow these technologies to scale much faster than we've been able to do in the past. And it's going to shock people in how much things change on the technology side, but also within the grid and within just our general life. Free energy in Australia, I think at some point in time, it's not going to be 3 hours. It's going to be 4, 5, 6 hours, 7 hours, 8 hours. It's going to keep increasing. And what's been done there is going to be adopted in other areas because once you have that excess capacity or its abundance, right? You've got a surplus, you've got an abundance of capacity and energy. It's a lever that allows you to do a lot of things that can create a lot of good in multiple areas.
Yeah, and especially the business that you mentioned, for a couple of cents, they're thinking viable or not. There may be hundreds other businesses waiting. They are not viable because the solar price
Yeah.
is 22 cents that the grids are offering. They maybe start thinking, oh, I can do at 8 cents, 3 cents solar, and suddenly say, no, I get electricity for free. Oh dear, I can do so much more, no?
Yeah, it's really interesting time that we live in. And I'm excited that we get to live in this transition of time and all these technologies being able to be implemented and deployed that, like I said, 10, 15 years ago, we used to talk about free electricity. It's here now.
Yes, yes. Thank you so much, Bill, for your time. I know that we have done almost an hour. We can continue on
Yep.
and on.
We can go for another 2 or 3, I'm sure.
I'll definitely connect. Is there anything else you wanted to share?
No, I really appreciate being on and being able to catch up with you, and interesting is to hear what you're up to. And if anybody wants to talk, you can look us up, Clearbook Energy Solutions or Clearbook Global. And then I'm on LinkedIn. So as soon as you publish this, I'll definitely be posting it and looking forward to staying in touch and come back on in 6 or 12 months and give you an update on everything. And maybe by then we've got 8 hours of free electricity in Australia.
Wonderful. I actually will try to post it today because I come back from home leave and holidays. So I do Mondays and Thursdays. So this may be the first episode that gets published immediately. I don't have to see with my editors and others. Again, I will do one other thing. Again, this is also for the listeners. In the next week or so, I'll get 3, 4 people and talk about the impact of this free electricity within Australia first, and to you, if you have the time, to talk about the global implication of Australia's experiment, which is a very smart one indeed.
Yeah, no, that'd be fantastic.
Thank you, Bill. Thank you so much.
Thank you, Sohail. Have a great day.
Thank you. Thank you for listening to Energypreneurs. Let's work together, electrifying everything. This podcast is available in audio form on your favorite platforms and in video on YouTube. See you on next episode. Please feel free to subscribe to our channel, and we always appreciate your comments.